Hello everyone, I am Julie Smiley, CIO for CDISC. Today I will be discussing technology-enabled standards and how we are leveraging technology, open source solutions, and AI for automating clinical data flows and artifacts. I will cover our vision for 360i in the AI Innovation Challenge. Then, I will discuss the achievements and findings from 360i Phase 1, followed by our plans for Phase 2. Let's begin with the vision for 360i. Today's clinical research operates in disconnected silos, with manual interpretation of protocols causing delays and errors. This leads to inefficiency, inconsistency, and increased cost. Lack of digital standards limits automation. Our strategic goal is to expand and enable standards-driven automation across the end-to-end study information lifecycle. This involves expanding, connecting, and digitizing our standards to reduce variability and increase automation. The 360i vision is to create a fully digital, standards-driven clinical development lifecycle. This ecosystem uses the Unified Study Definitions Model, or USDM, as its foundation, enabling machine-readable data flows and open-source tools. Phase 1 focused on the process from study design through the generation of machine-executable specifications and SDTM dataset creation. This includes defining the protocol outline and schedule of activities within USDM using the CDISC library. Phase 1 focused on the path from digital protocol to SDTM dataset generation. Phase 2 will continue through analysis and submission, with pre-work already started on defining analysis concepts. Next, let's discuss the CDISC AI Innovation Challenge. The 2025 AI Innovation Challenge aimed to advance standards through innovation. It was open to CDISC members and encouraged the submission of open-source or commercial solutions. The challenge was a global call to apply AI and machine learning with CDISC standards, focusing on implementation rather than theory. It tested how AI can accelerate a digital data flow, starting with USDM. The challenge focused on 3 use cases: digital protocols with USDM, biomedical concepts, and semantic traceability. We received 22 submissions from over 40 organizations using various approaches. Solutions were surprisingly close to production. Standards were most effective when structured and executable. AI provided value in scale, linkage, and interpretation. Trust and explainability were emphasized over novelty. Key questions remain regarding building trust in AI outputs and making solutions adoptable beyond pilots. We also need to define where openness helps and what ecosystem support is needed. AI doesn't replace standards, it amplifies them. And standards don't limit innovation, they make it scalable. Now let's review the achievements and findings from 360i Phase 1. In the design phase, we achieved detailed user stories and a digital schedule of activities linked to biomedical concepts. Challenges include interpreting protocol information and the need for an open-source USDM authoring tool. For building define.xml and shell datasets, we identified all necessary metadata and used biomedical concepts to query the CDISC library. The main challenges were the large process flow and the need for study-specific operational metadata. In building CRFs and annotated CRFs, we generated the necessary ODM file and HTML renditions. Challenges included missing CRF specializations and forms metadata in USDM, requiring workarounds. For generating SDTM datasets, we successfully used the open-source SDTM OKR package. Challenges included dealing with non-standard, non-tabular data, and the need for tool-agnostic transformation logic.
Now let's see some recorded demonstrations of what the teams have achieved so far with 360i Phase 1. This diagram represents the data flow from a digital protocol through SDTM dataset generation. Traditionally, this process has been very linear, but we wanted to prove out that many artifacts can be generated much earlier in the process with a digital protocol. On the right-hand side, we have links for the Google Colab notebook, as well as demo videos for each deliverable. Note that these videos are repeated for some deliverables because the team created several artifacts together. For example, the video for deliverables 2 and 4 are the same because the CRFs and annotated CRFs were demonstrated together. Let's first take a look at our Google Colab notebook. This is what we use to connect everything end-to-end, including code, API calls, and executing open source tools to produce deliverables. Colab is a free cloud-based environment that lets you run Python, R, and other code directly in your browser. Think of it like a Jupyter notebook hosted by Google. It combines text, code, and outputs all in one place without needing any local setup. It's especially useful for demonstrations like this because we can share and run the same code consistently from protocol to submission. This includes running executable code and connecting programmatically to external resources such as GitHub repos, the CDISC library, CDISC Open Rules Engine, and other open source solutions. Within this repository, there are multiple files, including the notebooks that you can download and open in Google Colab. There is also a README file that will help you get started. You can see that down here. It gives you the links to the notebook, describes the notebooks, and then there's how-tos on doing different things with the notebook. And then there's also links to the other resources that I showed in the slides. Again, this is our main Google Colab notebook, and we can see it here, but it's not executable here. You can open it in Google Colab, download it and open it there to be able to execute it. So within this, you can see that there's a lot of contextual information describing the initiative overall, and then you can scroll down and see different sections. So for example, our first step is building a digital protocol with USDM. So as we scroll through, you can see it has things like diagrams that explain the different open source tools that we use, how things were done, the order of doing things, etc., including the executable code. All right, now that you've had a preview of the notebook, let's go back to our videos. So now let's show some demonstrations of this notebook being executed. Again, all of these videos are running against that same notebook, and so it's just demonstrations. Let's start with our digital protocol. Let's take a look at how we build a digital protocol using a few tools and the Unified Study Definitions Model, or USDM. Traditionally, studies are designed manually with a number of stakeholders contributing to a protocol document. With 360i, we standardize this process and automate it using the USDM to create digital machine-readable protocol that connects all downstream artifacts through shared biomedical concepts. We use two different approaches to generate the digital study design in USDM: Open Study Builder, or OSB, and D4K's Study Definitions Workbench, or SCW, each drawing on standardized content from the CDISC library. While OSB provided an online interface and SCW supported offline development, both produce machine-readable USDM files that drive automation across a clinical data pipeline. The Excel design template from SCW generates a USDM version 4 JSON file aligned with CDISC standards. This digital protocol defines the schedule of activities, links activities to biomedical concepts, and becomes the foundation for downstream automation in 360i. In this first step, we'll be creating and validating the digital study design. I've already run the cell for creating and validating the design. In this step, we need to configure the environment to be used throughout the notebook. This includes installing dependencies, setting variables and functions, and mounting our Google Drive, which we're using as the operational data store, and creating directories within it. You can see this has already been run. Again, we can mount the Google Drive. This has already been mounted for loading everything into our operational data store. And now that we have our environment set up, we can clone our validation utility repository from GitHub. This is a GitHub repository for validating the USDM JSON file, and that has already been run as well. It's one of the many utilities you'll see used throughout 360i. Next, we're going to upload the study design workbook in Excel. Again, I've already uploaded this for the demo, so we can move along. And we can view the schedule of activities, which has already been run. And this is coming directly from the spreadsheet, the workbook that we uploaded for SCW, not from the JSON file. Then from the SCW, we generated the JSON file, and next we'll upload that into our workbook, and that has already been done as well. So now that we have everything in our workbook or in our notebook that we need to be able to generate the USDM study design, in JSON for use downstream, we can move on. So we can view the uploaded JSON file. We'll run that live. And here you can see that we have everything in our JSON version 4.0 file. And this again will help with all the automation downstream. And again, this is for the schema validation from the GitHub repository that we uploaded. And that validation ran successfully, as we see here. And then next, we're going to use this to also validate against our CDISC open rules. So first, we need to install our core engine within the environment. So let's do that. And then next, we can actually run our conformance rules. And this will take a moment, but once we have all of our conformance rules run, we'll create a list of those, and you'll be able to see those and then any failures. Okay, now that that's complete, we can take a look at the list of rules that have run against that JSON file. To narrow it down, let's also look at those that were actual failures. So we did have 2 failures against this, and we can look at this in different formats. Sorry, we're going to go ahead and stop that here. The last steps that are going to be shown are just putting everything back into the operational data store so they can be used downstream. Now that we have our digital protocol in USDM JSON format, let's generate our CRF specifications in ODM and HTML rendering of our CRFs, as well as our annotated CRFs. To do this, we ingested the USDM JSON file, the associated biomedical concepts, including the dataset specializations, and we utilized the CDISC eCRF portal. We also created some templated content, and from this, we're able to generate our CRFs and annotated CRFs. First, we needed to clone our GitHub repository used to automate these artifacts. So let's run that. And that ran pretty quickly. Now we can generate the CRFs and annotated CRFs, including HTML rendering of both, as well as the ODM XML specs for the vital signs domain. We can see that that ran. So we're also going to do the same now for our demographics domain. But first, let's check this out within our directory. So we're going to place those files into our CRF directory and then run this again, but now for our demographics domain. And again, we can verify those files went into our CRF directory. And next up, we're going to take a look at what was created starting with the CRF. So let's display these. So we can take a look at our vital signs CRF. As you can see, this is interactive. You can enter content in it. Of course, it's not getting stored anywhere, but it's just to show how this was rendered. And this is all the way throughout. So this is a good way to be able to view and edit, go back and edit, how things need to be displayed. But again, this was based on the eCRF portal specifications as well as what was defined within the protocol. Now let's look at this for our vital signs domain in terms of our annotated CRFs. So in addition to just being rendered, you can also see that we have our biomedical concepts annotated, we have our code list annotated, and our direct mappings or indirect mappings for transformation logic. So we can also take a look at our ODM file. So let's run that. And there you go. You see our ODM there. And from this, you can kind of see different things within it. Let's kind of scroll up. So here we can see our biomedical concepts. So here we have one for our C code C25299 and diastolic blood pressure. We can also see our code list references as well as our code list details. So again, in the interest of time, we're going to go ahead and cut that video short as well. Really what's left is just being able to generate all that and add it to our operational data store. And so, we saw the main heart of that, generating our CRFs, annotated CRFs in the ODM file. Thank you.
While we don't have time to go through all of these videos, you can access this Sankey diagram and the videos either from these slides or from the GitHub repo. Here is a list of the different GitHub repositories used in the demo. The 360i repo, which includes multiple notebooks, can be accessed via the provided GitHub link. This repository is under continuous development. These public GitHub repositories use open source libraries. The process involves forking the repository, creating a new branch, and raising a pull request to propose changes to the original parent branch. Now that we have reviewed Phase 1, let's look at the plans for 360i Phase 2, which recently kicked off. Phase 2 is focused on operationalizing the vision. Key deliverables include a machine-readable protocol model, a standardized analysis concept model, automated define and dataset generation, and a digital data transfer agreement model. We are focused on two primary use cases. One is a breast cancer endpoint of progression-free survival, and the other is an Alzheimer's endpoint of change from baseline. Our goal is to demonstrate selection and configuration of these endpoints from protocol through analysis at the CDISC US Interchange in October. You've heard where 360i Phase 2 is going, and we want you to join us on the journey. We believe it's a great partnership that offers purpose, connection, and growth. We are actively transitioning into Phase 2, which brings new milestones for our volunteers and teams. We will create a foundation for these milestones, built on weekly workstream meetings, project management support, and engaging our volunteer contributors. There are 4 main work streams that make up 360i Phase 2, and we are looking to recruit volunteers for 3 of them. Engagement is really important for project success. We are asking volunteers to contribute an estimate of 20 hours per month. Even if you signed up to volunteer in Phase 1, we are interested to hear where you would like to participate in Phase 2. If you are familiar with the CDISC volunteer page on our website, please do this form first to share your interest. Feel free to also share with your colleagues. We will use the information to best match volunteers with opportunities. Finally, before we close, I would like to mention that we have an upcoming European CDISC Interchange in May in Milan, Italy. We hope you will consider joining us. Thanks so much for your time and opportunity to present.